for two-way acceptor program that is created using Java 11 programming language. So this is just the test class that will instantiate the two-way acceptor program or class, and we will then invoke the run machine of that class in order to evaluate the given two-way acceptor program, which is this text file, which corresponds to this text file in this directory inside the project, and also the omega source file, which is this file, which corresponds to this file, which contains all the sample omega values that we will be evaluating. So both the program text and omega text files will be the argument for the run machine program, which will which has this corresponding implementation. So the run machine that is called, if we run this test, is gonna call 1, 2, 3, 4, 5 functions defined privately within the two-way acceptor class. So the first one will just display the project details. So this is just a simple printout of the project details, and then the next one would be load TW program files. So this will just basically invoke the function to load the program files, which was defined in this argument program file. So what it does is just a basic Java IO implementations using the scanner. It will just parse this file line by line and then save each line in a list of string, which will be then used later on. So it will just basically read and load all these files and then put it in the per line in this list of string. And then the next function that will be called is load omega from file. So this is basic, somewhat similar to this one, but instead this one will load all the sample omega inputs in this omega text file here, and then it will add all the omega lines in this list of string omega lines, and it will return it. And then once it's returned, it will be assigned to this variable, this substring, which will be then used to this actual to this part of the program wherein we are looping in all the values. So we are looping in all the values from here. Now, so this for loop just basically means that we're going through each of the values here in this omega text file. Now, there's a simple validation is omega is valid omega. So this is just a Boolean function, which is just doing a high level validation on the inputs or the omegas in the input text file. So it's just basically checking that it's going to return true here if it's not empty. So if it's empty, it's gonna initialize this omega boolean to false and it will be returned. So it shouldn't be empty. So it shouldn't be an empty line. Um, it's not valid if it does not start with S or sharp, the sharp symbol, and if it's also or it does not end with the sharp symbol. So the accepted format is that it's always starts and ends with the sharp symbol, and it should only contain the three characters. So this is just a simple regex in Java, which means that we are enforcing that there should only be A, B, and sharp symbol found in each line of the input text file. After that, once that returns true, it will then call this evaluate omega function. Else, it will just print invalid and the line in the text file that has an invalid format which does not correspond or comply to the following validations. This is the core functionality, the evaluate omega for O, which means each line, since we are looping here. These omegas correspond to each to the list of all these lines, and each O is corresponding to each line here. So we are just basically looping and passing it to the evaluate omega, which what's this is the core functionality. So what the first thing that's happening is that it will pass this first line as the parameter, and then it will convert into array of characters. Once the array of characters is placed, we're just gonna store it in this variable omega called omega, and then we just initialize the state to 0. So this is just a placeholder. And Here we are just basically looping in all the characters in this line. So we are starting so we know that the first value of the character is index 0, which corresponds to the sharp. So we are skipping that. That's why we are already starting with the value of 1. Now, since we are not really validating this, it's just an indication that this is the start and we are to evaluate the first character of the omega. Now, um, based on the rule, um, if we found an A here in the program, if we found an A during the state 1, so this is basically the state 1. If we found an A, it should go to state 2. Similarly to this state diagram, this is the R. So this state 1 here, if this is A, we should go to state 2. So that is actually what's happening. In order to know the value of the next state, which we initialize from 0, the next state will be, the value of this will be overridden by this function get next state from state 1, wherein in this get next state from state 1, what it does is actually, um, it's going to parse the program lines get 0, so this line, and it handles what should be the return value based on the character. So if it's A, it will just gonna parse or substring this line, and it will return, if A, it will just return this 2. Similarly for B, it will just return this value 1, and if it's sharp, it will return 4. So it's just returning what state it should be in based on the character in this whole first line. After that, since we know that we are already here in the first state and we got an A, it's going to return 2. So the next state value will be equal to 2. So this one is not true because it's not 1, because it's not B. This one is not true, it's not 4 because it's not a sharp. We are at A. And if it is A, based on the program, we need to go to state 2. So here, this is actually the part of the code that handles the state 2. So when A is found during the state 1, we need to go to, so this is the actual implementation of state 2. Now, since we are already here at the first state, we need to move to the next character here. Next state. Now, in state 2, if we found another A, we should go back to 1 here. Now, this is the part where actually handles that scenario. So it's not going here. It's not going here. This is actually the part of uh, the program that actually checks for the character. This is not true. It's not 2 because we did not find B. We are still here. We did not find B, so it's not gonna evaluate true here. This is not gonna evaluate to 3 because we did not find the sharp because it's an A, so it's not gonna go in here. And so it's gonna evaluate a true here. If A is found in the state 2, go back to state 1. So if that is the case, it will just break. Break means it's just going to break the loop, this loop, wherein it's actually the one traversing the characters from the part where we found the A in state 1 here. So once it gets back to, once it hits the line 79 for the break, it's going to exit this loop. It's going to exit this loop, and then we already incremented the value of I here, so it has an updated value of pi, and then it's going to hit A again here. So if we're going back to state 1, wherein the value of I is already updated, so we are already here. So it's going to call again the same function in order to know what should be the next state if we found an A. So it's need to go to, if it's an A, you need to go to 2 again. So this is false, and this is true again. Now, if it is true, we're gonna increment the value of I. So we're looking at the next character. So it's now a B. So if you found a B according to the program, we need to stay at state 2. So here, this is actually the if condition that handles that. Ignore all B's. Ignore all B's according to the state diagram. So ignore all B's, that's true. So we just increment I, so we can look at the next character and then continue, meaning we're still in state 2, and we're just going to continue with this loop until we're not at the end of the tape. So next one, it's going to be an A. So what's going to happen if it's an A? If it's going to go here again, if it's A found state 2, break again, and you're going to go back to the state 1, which is the outer loop here. It has the updated value of I. Evaluate again an A. So it's gonna found an A again here. So here again, it's gonna find an A and then break until it gets to the pound sign. So the part where it's get accepted is that um, this part, this get next state from state 2, which represents this. If we are already on the part of the tape where we found the sharp sign, it's gonna return 3, which will be handled by this part of the code. And it's just gonna print the accepted omega. And then it will just set the value for J and I, so it will just basically end the whole evaluation of this whole line and proceed to the next one. So if we run the test class using this program file and this program text file as the input and run, this is what's gonna look like. So here, this is the displaying project details. This is the first part of the run machine function. Then loading of the of the program file and loading of the input file. So that's done. And then here it will be displaying the results of each line from your input omega input file that contain your sample omegas. So this means that so we know the rule that it should be um again, the two-way acceptors problem is that omega of characters A and B, where the number of A is odd. So here, which corresponds to this first value in the input file, A, that is rejected because there's an an even number of A's. So this one is accepted because it has an odd number of A, and A. So I also handled these are just some values that I played around on whether they should be rejected or not. So this is obviously rejected because it does not have value it doesn't have a value for A. This is rejected because there's no value for A as well. This is accepted A1 because 1 is an odd number and it's present. So there you go. It's accepted. This is accepted as well for 3 A's and so on. This is accepted with single A. For the other inputs, I have here some samples like the valid or empty line, which was handled by the validation. So it's invalid empty line. If there's a found character or that is not supported, that is not sharp A or B, it's handled by this and will be printed as invalid. This one does not end or it does not start with the sharp sign, so that's invalid. This one starts and ends with sharp sign, but there's an invalid character X here, so that's an invalid and will not be processed. And this one, invalid character